a little review from the last lesson. I want to see if anybody remembers anything from the last lesson. And what are some of the major ideas? I'll start with a simple statement, P of A, maybe just to trigger your memories. And I'd love someone to either raise their hand and just audibly tell us what they remember, or put it in the chat. Let's just do a quick little, what is probability all about? What is this thing called probability about? What are some of the words we need to know? What are some of the symbols? Just do a quick little rewind to the previous lesson. Who can remember something from the previous lesson? You can ask to unmute by raising your hand, or you can put it in the chats. So probability is how likely something is to happen. It's a number that expresses how likely something is to happen. I like that, Hariva. That is great. And can that number be any number, or is there a boundary for it? So generally, we talk about the probability scale going from 0 to 1, where 1 is certain and 0 is impossible. Now, the other thing, there was an equation that we used that was probably the most important thing in the previous lesson. I want to know what was in this equation. So P of A means the probability of the event A happening. And I want to know how does this equation work? So Komotsile, you divide the number of chances with the n number. Okay, I know what you're going for there. So I like to say it's the number of possible outcomes over the number of favorable outcomes. This is basically the most important equation in the whole of probability. Whenever you have some event A, there's the example we used in the previous lesson was the idea of a dice. There's probably 6 possible options, okay? Now, if the event is throwing an even number, of those 6 possible options, only 3 of them are favorable. And so if it was the probability of, let's just say, E for even, if it was the probability of E for even, there's 6 possibles, but there are only 3 favorables. And so we would say the probability of throwing an even number with a dice is 50%. Now, I see Nolwazi has got number of outcomes favorable divided by A over the sample space. Yes. So the number of possible outcomes is also often represented by, we call it N of S, or the number of items in the sample space. And then the number of favorable items is just the N of whatever event we are trying to figure out the probability of. So in this case, it would be N of A, or the one below it would be N of E. And N just stands for the number of items in that particular set. Okay. Is there anything else that you can recall that was important? So I think that's the main idea. The other thing that we briefly discussed was different ways of visualizing the number of possible outcomes. And the techniques that we will come across in this unit are things called Venn diagrams, which we're going to spend a bit of time with today. We're going to talk a little bit about tree diagrams. And then we also talk about tables. So when we learn this section, we have to learn how to work with that formula and these 3 types of structures: Venn diagrams, tree diagrams, and tables. And these just help us understand possible outcomes and favorable outcomes. That's what these diagrams help us do. Then the other thing that we're going to spend a little bit of time on today is identities. And if we talk about sets, there's one identity that's going to come up today, which is that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B, which is a little bit of it looks a bit strange the first time you see it. So I just want to point that out at the moment. It's going to come up in the questions today, and we're going to learn it as we go. And this is called the additive identity. It says, look, what is the probability of A or B occurring? it's the probability of A occurring plus the probability of B minus the probability of A and B occurring. However, in some situations, if it's a particular type of set, we can ignore certain parts of this, but we'll get to that later. Just want to check how many people have seen this formula before. Thumbs up if you've seen it before, thumbs down if you've never seen it before. Okay, so it's one thing to see it, it's another thing to actually know how to use it. So today we will try and unpack what it actually means in terms of Venn diagrams, because this comes from Venn diagrams. And sometimes it's also written in another form. The other way it's written is the number of items in A or B is equal to the number of items in A and B. So our goal today is maybe to understand this a little bit better and also learn how it's connected to Venn diagrams. Okay, so it's not a problem if you don't know what it is yet. That's coming your way soon. Okay, then let's start with the questions. There was one bit from the last lesson that I want to finish off with, and then I'll start the new stuff. So when we calculate probability, sometimes it's not theoretical, it's experimental, or it's based on some real world trials. And if something happens in the real world, we call that relative frequency. And I want to see if you read this question, using what you learned in the previous lesson, can you answer this question for me? So it's one of those like sort of pointy thumbtack things, and it's been tested 100 times, and it's found that it lands upwards 38 times. Based on this real world experiment, what is the relative frequency or the experimental probability of landing thumbs up? So this is based on real world trials. It's not based on a theoretical thing. And the number of possible trials is 100. And the number of favorable outcomes is going to be 38. And so which option is going to correspond to that? 0.38. Well, there's no 0.38, but we can see B is the closest. If we round off to one decimal place, B will be the answer. So this isn't that common, but just know that if they ask you to work out experimental probability, it's still the same formula, but it's just based on real world events. Now, the relationship between experimental and theoretical, I'll maybe cover later in the series, but for now, it's just important to know that if they give you something like this, you can calculate it. Okay, I like what I saw there though. Let's do one more like this one with relative frequency or experimental probability. And this is from the pages of a book, and it is a count of the different letters that were occurring on a certain page. And they want you to work out the relative frequency of A or the experimental probability of getting an A on this page. Which one do you think it's going to be? See if you can work that out. We have the event of getting an A, and it comes up 126 times. The event of an E is 201. Now, we're only interested in the event of having a vowel of A, but we need to know how many possible outcomes are there. So when I added it up on my calculator, I got 600 possible outcomes, right? So if I added up this, there were 600 letters on the page, or vowels on the page, and we're interested in what is the relative frequency of A, or what's the probability of getting an A. And so for me, it has to be that. Now, I need my calculator. We should get 0.21, or we could even say 21% would be another way of saying it, but 0.21 should be the right answer. Okay, so if they give you real world situations like this and they ask you to calculate relative frequency, this is how you do it. Give me a thumbs up if you feel comfortable with this, thumbs down if you feel a bit unsure. Okay, fantastic. Let's move on up. So let us begin our journey into the world of Venn diagrams. So when we talk about Venn diagrams, we can talk about the number of elements in a set, and we can also talk about the probability of the elements in that set. To start with here, I'm going to give you the numbers 1 to 9. So in this particular story, we have the numbers 1 to 9. That is our sample space. And within our sample space, which is represented by the rectangular diagram, we have two events inside that. We have the event of A, which has the numbers 1, 2, 3, 5, 7, and the event B. I want you to take this drawing as it is and put the numbers in the correct place for the Venn diagram. And if you are unsure, I'd like you to ask a question, but I want you to just, for now, just take a guess where you think they would go. So you've got the numbers 1 to 9, you've got the elements for A and for B. Where do you think these would go in the Venn diagram drawing? I'm assuming you had some basic exposure to Venn diagrams. If you haven't, now's a great time to ask your question. So I want you to draw this on your page. You're drawing your Venn diagram. You've got A, you've got B, and I want you to think about where these elements go. So are there any elements, I'll give you a little sneaky clue, that are in A and B? How many of these elements within the set are in A and B? Maybe that's a good one to help you get going. So is there anything which is in A and B? I see the number 3 is in A and B, and the number 5, and the number 7, and the number 1. So the set that is, the elements that are in both of these, for me, are going to be 1, 3, 5, and 7. So we say that this is the intersection of A and B. Sometimes people use like almost an unhappy face for and, but you should get 1, 3, 5, and 7 going here. Now what I want you to do is I want you to try and figure out what goes in this bit here, which is only in B and not in A, what's in here, and if there's anything out here. So see if you can do that. And then once you are done with that, let me know, or let me know what your answer is. A is 2. Who else has some answers? Someone said 2 goes in A. I think that's, and B is in 9. Yeah. So we know that 2 is only in A, but it's not in B. We know 9 is only in B and not in A. So how many items have we ticked off? We've used 6 items so far, but there should be some other items that we haven't used yet. What are the items that are left that we haven't used? And where would they go in this drawing? Okay, so we have 4, that's definitely going to be outside because it's not in A or B. What else is going to be outside of A or B? So we're going to have 6, and we're also going to have 8. Yeah. And so this is an example of a set with a Venn diagram where you have certain elements in different parts of the different regions in the Venn diagram. Okay, I'm going to ask you now a probability question connected to this, but you've done very well there. What is the probability of A occurring? What is the probability of A occurring for this particular Venn diagram? Can you work out only, yeah, so what is the probability of only A occurring? And remember that formula that I said before. So how many items are there in the sample space? How many items are there in A? Okay, now, in the sample space, there are 9 items, 1 to 9, but how many of them are in A? I count, from what I can see, 1, 2, 3, 4, 5 elements are in A. And so the probability of getting the event A is going to be 5 out of 9, because there's 5 elements inside of this Venn diagram. So take a moment to think about that. If there's a question, raise your hand. I see quite a few of you, that caught quite a few of you, and so I'm going to slow down. Oh, so Nawazi, I meant as an A, the probability of A occurring in this whole diagram. So maybe there was a bit of a mix up there. So not just only A. Yeah. Let me go to whose hand was up there? I missed it. Yeah.
Sam Kesiwe.
Yes. Hey, Sam Kesiwe.
Sam Kesiwe, can you please unmute on the side?
Good.
She's not unmuting.
Okay, it's fine. I tell you what, let's go on to a second question where we use this same idea. And then I'm just going to point out, let's have a go at another question like this. Okay, so 150 people were asked which type of movie they like to watch. Draw a Venn diagram to illustrate this information. See if you can draw a Venn diagram to illustrate this information. So you start with the sample space, which you know is this number here. Mm-hmm. So I'll give you a hint. I would probably say because 23 said they like both, you're definitely going to have a circle that overlaps like this. And you can have A, and then you can have C. And what I would do is I would start by saying, we know that 23 like both. Now, can you work out what the other regions need to have in order to answer this question? And if you're unsure, I encourage you to raise your hand. I'd love to have a question. Remember that you know in total there are 80 people that liked action, and you know 23 already liked action and comedy. So I'm going to ask you this, what is going to be in this region over here? I want everyone to tell me in the chat or over the audio, what's going to be in that region? Exactly, Zinclair. It's going to be 80 minus 23, which gives us what? Gives us 57. Yeah, awesome. Now, what about the other regions? How do we work those out? Mikle, yeah, let's come to you. Hi, Mikle.
Hi, sir.
Hey, what's in this region?
It would be 55 minus the 23. That's for both, which is equal to 32.
Which is going to be 32. Yeah, 55 minus 23, 32. Absolutely. And this region outside? What about this region? How am I going to work that out? Aha, Mikle, do you know how you work out that bit? Okay, so all we do, can you hear me? Okay, 150.
I think we lost her.
Minus 57, minus 23, minus 32. 150.
Oh.
And so you should get, what should you get? Put it in the chat. I want to see. I've got my answer here. It's going to be 38. Yeah, awesome. So what the Venn diagram helps us do is it works out the number of possible outcomes, and it also helps us understand the different groups within sets. Okay, now I'm going to ask you a couple of probability questions. Say you chose a random person from this Venn diagram. What is the probability that they like both action and comedy? So A and C. Another way of writing this, I'm going to write it in both notations, is this would mean the same thing. What is the probability that a random person you choose from this group likes both action and comedy? So what is the probability that this person, that somebody from this group likes action and comedy? So the region we're going to be looking at for action and comedy, there are going to be 23 people who like, we call this the intersection of the two sets. And so now the question is, how do I link that to my probability formula? So you're going to get 23 over 150, since that is the total number of possibles, is 150, and the favorable outcome for the question is 23.
Mr.
And so
yeah. Sorry, Mr. Is, can you please explain for AC Mike how you got the values for A and C?
So what I did was I started with the centermost area. It basically said 23 liked both action and comedy. And so what I did was I drew the two sets have people who like both. We say that they have an intersection. And so what I did was I started by saying whatever that number is, I put that in the middle, 23. And then I said, well, I know that for example, action has 80 people in total. And so I just went 80 minus 23 in order to find out that this was 57. So I basically work from the inside out. So I'll do another one of these in a moment, but let's go with this question. What is the probability of someone liking action or comedy? So what is the probability of someone liking a random person chosen from this group of liking action or comedy? Think about it. So for me, action or comedy, the number of possible outcomes is still 150, but the number of favorable outcomes is going to be, so it's going to be this region, and this region. So this is going to be 57 plus 23 plus 32, because any of these are favorable. If you like action or comedy, or basically it's all those region in between. So what's that going to be if you add that up? It's going to be 57 plus 23 plus 32. It's going to be 112 out of 150. Now we're almost at break time, but I just want to, when we say or, it can be either the one or the other or both. So that's why I include, basically, as long as it's not the 38 on the outside, all right, it is going to be, it's a favorable outcome. So the only ones I'm excluding are the 58. Everything else is a favorable outcome. And that's why the probability will be 112 divided by 150. If you need to have it as decimal, you can do that. Now, just to show you guys that if we wrote this out, that identity would still be true here. Okay, I tell you what, it is time for a break. And so what I want to do is pause for a second, and then we'll carry on after the break. But I would love you, ladies and gentlemen, to turn on your cameras and stretch with me now. Let's do this. Okay.
Come on, guys. Please turn your cameras on. Let's see your lovely faces.
Let's feel those happy faces.
Break.
Nolwazi, on your feet. Let's do it. William, on your feet. Let's go. Shine brightly. Ah, there we go. There we go. Michle, I can see you on. There we go. Williams.
Shout out to you guys.
Okay, and let's stretch it out. There we go. There we go. All right. Oh, I love Cape Town. Awesome, Debo. You'll see how much you like Cape Town when you come and visit.
Oh, I can't wait.
Oh, guys, how good does that feel? Oh my goodness, I feel alive. There we go. Oh
Yes.
Such good feelings.
Rejuvenating, guys.
I'm going to show these
diagrams too fast.
Okay. Quick little brain break. Here is the brain break today. I add 5 to 9 and get 2. The answer is correct, but how? So I add 5 to 9 and get 2. Rosario, what do you think? Should I give you a hint? The hint is that it hangs on the wall. It hangs on the wall. Aha, yes. I see some folk have got it now. So if you're at 9 o'clock and you add 5, then where do you get to? You get to 2. And that is the sneaky brain break for today. So I see I caught, yes. Ari, let's come to you. Was that a hand up? Okay. Cool, Mensa. Let's keep on rolling with our probability show. Okay, so in this question, I just wanted to show you that if you think of that identity that I spoke about earlier in the lesson, if you have basically the probability of A or C, I'll get rid of that, was going to be equal to the probability of A, which in this case would just be 57 plus 23. So that would be 80 over 150 plus probability of C, which is 23 plus 32. So that is 55 over 150 minus the probability of A and B, which is 23 over 150. So just to show you that this does actually, that formula from earlier in the lesson, I know it's still a little bit weird, but just to show you it does actually work in the context of a kind of real world situation here, a real question. The probability of A or C is equal to the probability of A plus the probability of C minus the probability of A and C. And I just wanted to show you that, but yeah, we'll come back to that in later lessons. So let us consider this question. This is a Venn diagram question, multiple choice. And what is the probability that a student chose to study Spanish, which is the correct option? What is the probability that the student chose to study Spanish? So the number of possible outcomes are 150 because we know it shows 150. Spanish is going to be this one, which means it's 53 over 150, which is C. Okay. What is the probability? This is going to be not one of the options here, but I want to test you. What is the probability that a student studies neither French or Spanish? So this is my own made up question. What is the probability? The way we would say it is, it's not, so it would be the fancy way. Actually, before I write it down, let me just say it verbally. What's the probability that a student takes neither French or Spanish?
Mr. Is?
What's your question?
Yeah.
Hi, sir.
Hey.
Sir, I have a question. Did you get the 53 over 150 by adding the 23 and the 30 together?
Yeah, that's exactly how I did it.
Oh, okay.
Can you see how they're both inside Spanish? It means that the students who, 23 of them, take Spanish and French, 30 take only French. But in total, it says chose to study Spanish. It's everybody inside that circle who decide to study Spanish. Now what I'm doing is asking how many people study neither, which is basically this region outside here. And what's that going to be? Well, it's just going to be 150 minus 60 minus 23 minus 30. So what's that number? 60 minus 30. So that's 37. And then for it to be a probability, I just have to divide by the number of possible outcomes. So it's 37 out of 150. Okay. What is, okay. So give me a thumbs up if you understand that. Give me a thumbs down if you don't understand that. Just want to, because I'm feeling some good questions coming along. Okay, now I want to ask you, so we know that this region out here is 37. What is the probability that somebody does not study French in this particular question? So the way I would say it is, what is the probability that someone does not study French? So we'd say the complement of F dash. F dash means not French. So what's the probability that somebody does not study French? Sonia Ishe, let me unmute for you. Hi.
Hello, sir.
How's it going?
I'm good, thank you. How are you?
Very good. How can I help?
So I wanted to ask the question where you got the 37 out of 150. I wanted the question. What was the question?
Okay, so the question is, I asked how many students, or what is the probability that a student doesn't take French or Spanish? So basically, they mustn't be in either of the two circles.
Okay, thank you.
Does that make sense? That's where, and I subtracted, I went 150 minus 60 minus 23 minus 30.
Yes, I get it, sir. Thank you.
Perfect. Now, this next question is a little bit harder, but if you think about it logically, what I've said is I want all the people who don't study French. And the way we do it in probability notation is we say F dash. So I want all these regions, basically, wherever the red is what I want. And so what's that probability? Well, it's still going to be 150 as the total, but how many regions are not, basically are not French speaking, or essentially, you're going to get 30 plus 37, which is 67 out of 150. Awesome. Okay, so all I wanted to show you is the Venn diagram is a way of working out possible outcomes and favorable outcomes. And it's a way of just understanding the groups within a question. The other thing that I've been showing you is this notation and this idea of a complement. So the complement of F is everything that is not in F. If I said to you, let's do one more just to check this. What is the probability of S dash, which is, in this situation, what is the probability that a student doesn't study Spanish? I really feel like we're making some progress here today. So we could say it is, or the student does not study Spanish, or the student is in the complement of that. So this is still 150. Now what's not in Spain? It's the 60 and the 37. And so it's going to be 97 over 150. Yeah. Awesome. Awesome, awesome,
Good
awesome.
work, guys.
I feel like we're getting the basic Venn diagram stuff is going well. Lusanda, what's your question?
So I wanted to know if it's fine when you said we must calculate the ones that don't speak Spanish. Is it fine if I said 30 plus 23 minus 150?
Aha, yes, very clever. Okay, so what you're using is the complementary identity. And the complementary identity says that if you want to work out P of F dash, you can just go 1 minus the probability of F. That's the complementary identity. And you are absolutely correct. And you get the same answer. Well done. That's a very insightful question. Okay. Let us do this multiple choice question. Let's do these two multiple choice questions. We're making good progress today. So we're going to talk about the word mutually exclusive. What does it mean to be mutually exclusive? And I want to see how many of you have come across this word before. So if two events S and T are mutually exclusive, then which of these statements is true? What does it mean for events to be mutually exclusive? Okay, so there's a couple of answers coming through. So if two events are mutually exclusive, it means if you're in the one event, you can't be in the other. So mutually exclusive events, we say that their intersection is empty. They have no overlap. So the correct option here, and this is new to some of you, is C. And what this is saying is it's using the unhappy face for and, but basically what it's saying is that the probability of an event or of an element being in both of these sets is nothing. It's 0. And the Venn diagram would look like this. It would be two circles that don't overlap. And so that would be mutually exclusive events. Another example of two mutually exclusive events, think of odds and evens on a dice. If you throw an odd number, can you throw a even number at the same time? It's not possible to have at the same time. So that's a very common example of mutually exclusive events. The Venn diagram will have no overlap. And this is the definition of mutually exclusive events. Any questions about that or comments? We have to use it. We'll use it in questions, but. Okay, then let's do another multiple choice question. In general, this is equal to what? Now, just to show you, the happy face is all. The unhappy face is and. Okay, some of you are being caught out here. So this one, it's not going to be that's for mutually exclusive events, guys. So this is in general. In general, the identity says that C or D will be equal to the probability of C plus the probability of D minus the probability of C and D. Now, in the situation where things are mutually exclusive, then this last bit over here would be 0 because there's no intersection, and so it falls away. But the general case is for all of that to be there, and in which case the answer should be D. So in general, the additive identity says the probability of C or D is equal to the probability of C plus the probability of D minus the bit where they overlap. And the Venn diagram for that is this one. And the reason we have to subtract the intersection is we're counting twice. So if we count the whole of A once and the whole of B once, we've counted that middle region twice. And that's why we have to subtract it at the end here. Whereas if the Venn diagram has had no overlap, that's why in that situation it would be A. Okay. I think I'll come back to this in later lessons. All I want to do today is lay the seed for this identity. It's a little bit complicated to see in algebra. It's easier to see in the actual questions. So let's do one more question, and then we're going to call it a thing for today. So last question of the day. In a class of 25 students, see if you can figure out how many students play football. I'll give you a little hint. So each student plays hockey, football, or both. And 15, so there's definitely going to be an overlap. And what did we do in the last question? We started with the middle. 15 students play 15 students play football and hockey. So now 18 play hockey, which makes me think that this must be 3 because that's 18. Now it says 25 students in total, but they each play hockey, football, or both. So there are actually no students. There's 0 students outside this thing, which makes these 2 circles add up to 25. So what does this F have to be? Well, it's going to be 25 minus 15 minus 3, which is equal to what? 25. And that is going to be 7. And so the answer is going to be A. Yeah. All right. So what was the goal today? The goal was to go from that initial definitional equation and to start to show you that we can represent possible outcomes and favorable outcomes in different ways. The different way today was mainly the Venn diagram. And so essentially, I just see some questions coming in there. Lusanda, the 3 came from here. So I was going 25 minus 15 minus, which is here, minus 3 minus, and then I got the 7. Okay,